Primms algorithm can be applied to procedural map generation, where all the nodes are all points on a graph. Here, let's start with a simple 3x3 grid. All the nodes are the squares, and the paths are the connections to the neighbouring nodes. So to create a maze using Primms algorithm, we start at one point in the graph, and it grows outwards from this graph. The standard version of the algorithm looks like this. It chooses an arbitrary node or vertex from the graph. Then it chooses the path with the smallest weight from the point. In maze generation, all paths have the same weight, so this choice is random. It then adds this new node to the minimal spanning tree and repeats step 2 and 3. So, let's see this in practice. First we choose a point at random and add it to the maze. Now let's colour in its neighbouring cells. These are all paths the maze generation could choose. One of these neighbours are randomly chosen, and a passage is formed from the original cell to the chosen neighbour. Now the neighbours of the chosen cell become possible paths too. This process repeats. Now let's say here the generator chooses a cell at 1, 0, so the top middle. It is adjacent to two cells that have already been chosen. The algorithm resolves this by simply choosing the in cell at random and creating an edge perpendicular to the in cell. And so this keeps going until the algorithm terminates as there's no more neighbouring cells, giving us a perfect maze. Now, let's implement this into Unity. To make a maze, we need several pieces of code to generate it. So let's create a game manager to take care of this. Now, to keep things clean and organised, it's always best to create folders to store all the scripts together. So I'll just create a folder called scripts, and we'll also need one called prefabs, which we'll use in later. So in the scripts folder, I'll just create a new script, call it cs_game manager. I'm also going to create a prefab of the game manager. So by doing that, create an empty game object, call it game manager, and attach a script to it. And in the prefabs folder, I drag the game manager into the folder. Now the game manager will simply begin the game, and we'll also want to restart it using space. So let's create functions for begin game and restart game. Now we want these to be private because they won't be used outside of the game manager. So void begin game, private void restart game. Now we'll be defining these later, but at the moment, when we start the game, we want it to call begin game, and every update we want to check if the space key is pressed. So if input get key down and the key code equals space, and we want it to call restart game. To begin the maze generation, we also need to create a maze. So let's create a maze script. Maze. This will hold all the code to create the maze itself. We want this to be a prefab so we can call it in the game. To do this, we'll create an empty game object, call it maze, and we'll attach the script to it. We then drag it to the prefab folder. Once that is done, we can now create a reference to the prefab in the game manager. So we will add two variables, one public and one private. So the public will hold the maze prefab itself, whilst the private will be an instance of the prefab which we'll be working with. Okay, now we can initialize our maze. So first, we want to declare the maze instance as a clone. We do this using the instantiate function. So within begin, we type maze instance will equal instantiate of the maze prefab as cs maze. So what this means is the maze instance will be a clone of the maze prefab. And during restart game, we want to destroy this. So this instance will be destroyed. And we want to call it again to create a new one. So we call begin game once more. So now let's try that out in Unity. So we go to the prefab folder, we just have to assign in the script what the maze prefab is. So we drag the maze prefab up to the right hand corner. So now when we click play, you'll be able to see that the game manager does its job, as there is a maze clone on the far left side on the object hierarchy. Firstly, we're going to create a flat maze by filling a grid with cells or nodes. So let's create a new script called maze cell. We'll call it cs_maze cell. Within this, we want to be able to say how big we want the maze. So let's create two integer variables. So it'll be public int isize x and isize z. We'll also need the cell prefab to instantiate or clone. So that'll be public again, maze cell prefab. I'll need a private one in which we'll be creating the reference to. Now we'll also need an array to store all the cells created, and this will be private as it won't be needed anywhere else. As it's dependent on the size, we didn't have the size of it initially, so we do not need a size in the brackets, and we'll just call it simply cells. Now let's create a prefab for the cell. So once again, we need to go to game object, create empty, and we'll call this one cell. And we'll drag our script to it. Now the cell is going to act like the floor, so we need to add a physical component. At this point, we're going to add a 3D object and the quad. Now as you can see, the quad is across the Y plane, and we want to rotate that 90 degrees on the x-axis. So it's more on the XZ plane, which is the one we are working with. Now the quad needs to be dragged onto the cell in the hierarchy to make it a child object. This cell can then be dragged into the prefab folder for it to be used, and we can delete the instance. Now in the maze, we need to drag the cell prefab into the right so it has a reference to it. Now before we move on, we'll be creating our maze in a random way, so we'll be using maze coordinates. As we're operating in 2D space, across the XZ plane, we will need to be using 2D vectors. Now there's not a convenient integer vector structure for Unity, so we'll need to create one. So we'll just create another script and call it int vector2. This is going to be a struct instead of a class, so we'll just delete the contents and create a struct. So we'll click public struct int vector2, and inside the struct we want two integers to store the x and z value of the coordinates. As we're using the x and z plane, it's only right to call it x and z, so public int xz. We also need a constructor to be able to create an int vector2. So this constructor will take in x and z values, so int x, int z, and set it to its own values. We'll also most likely be adding these together at some point, so let's create an overload operator. This will take in two vectors and add them together. So it's a public static int vector2 operator plus. So it will take in two vector2s Now vector2s are added simply by adding the x coordinates together and adding the z coordinates together. So I'm going to create a temporary vector2, and so temporary x value will be equal to a's x plus b's x, and the temporary z value will be equal to a's Z and BZ. And we just simply return the temporary vector. So to be able to declare int vector2 on other scripts, we'll need to save a custom script with Unity, and to do this we simply add the serializable attribute from the system namespace. So at the top here we just put system, add this to our maze. So let's change the size in Game Manager to a vector2. So let's delete that. Let's put int vector2 and we'll call this iSize. We also want to declare coordinates in maze cell. So if we go to maze cell, public int vector2 coordinates. We should now add a generate function to the maze script, which will construct the maze. We are going to make the generate function an IEnumerator so we can create a coroutine. This will allow us to see the maze be created one cell at a time. So we won't be needing this. And the generate function is going to be an IEnumerator. So we can create a coroutine. This will allow us to see the maze be created one cell at a time. So we will need a step delay for this. So we'll simply create a public float generation step delay. So we want to wait for seconds and now here is where we'll set the size of our cell prefab. So it will consist of new maze cells of size X by iSize Z. We will now create a double for loop to create all the cells. So all the X values and all the Z values will be covered. So for int I equals 0, I is less than iSize X, and then for int j equals 0, j is less than I size Z. So for the cells, we will return the delay and then we will create a cell. Now we haven't created the create function yet, but we'll do that just in a moment. And that will take in I and j. So now we'll define the create cell function. We want it to take in two values, which will be its coordinates. We also want to create a new cell that is a clone of the prefab, so we'll instantiate it. So the bottom, so this will be a private void, as it will only be accessible in the maze script. And it will take in an int vector2. So first of all, we'll create a new maze cell, or a new cell, and it will be a copy, so we instantiate it, of the cell prefab. We then want to place the new cell into our array. So in our array of cells, it will be placed according to its coordinates, so its x coordinates and its z coordinates, and that will equal a new cell. We also want to set the coordinates inputted as the actual new cell coordinates. So new cell coordinates equals the coordinates inputted. To be able to keep track of the cells, we'll name them accordingly to their position in the grid. So the new cell's name is equal to maze cell plus its x coordinate and its z coordinate. We then need to set its position and make it a child of our maze. So to make it a child, we put new cell, transform.parent equals transform. So that will state that the new cell's parent is the maze itself. And we also want to set the new cell's actual position to align within the grid. So create a new vector 3, and its x coordinates is the coordinates minus size times by 0.5f plus 0.5f, and it will have no y coordinates because we want it all on a flat plane, and the z coordinates are the same. Now the 0.5f comes from half the size of the cell, so it will align the position so the entire grid is centres. So now that we've created a generate function, we want to call this in the game manager. So we start a coroutine of the maze instance generate. And in the destroy or restart function, we want to stop all coroutines. So now in the Unity editor, I'm just going to position my main camera so it's at the centre, rotated 90 degrees so it's facing down, and I want the Y position to be 20. So now in our maze, I'm just going to change the size to 20 by 20, and the maze cell prefab, drag the maze cell in. Now let's change our step delay to 0.1, and when we click play, we can see that a maze is being generated. However, we want the maze to be randomly generated, and this is obviously not. So it's time to implement Primms Algorithm. So let's change the generate function so instead of a for loop, it goes through random coordinates. So to make this work, we need to add a random coordinate property to the maze that produces coordinates inside of it. So we create public int vector2 random coordinates, and it will get so it will return a new int vector2 with a random number between the range of 0 and the size we stated. We also want the same to happen on the z-axis. So the random coordinates will be in int vector2, and it's going to return a new vector with a random number between 0 and the length of the grid. The contains coordinate will be a simple boolean, so a true or false statement, contains coordinates that will take in an int vector2 and check if it's within the grid itself. So it will return true if coordinates.x is bigger than 0 and the x coordinates is smaller than the size. We also want it to be true if the z coordinates are bigger than 0 and smaller than the height. And now we need to import this into the generate function. So let's get rid of the for loop and instead we'll have int vector2 coordinates equal random coordinates. So contains coordinates, so while the random coordinates chosen are inside the grid, we want it to create a cell. Just change. And the coordinates Z will simply increase by 1 each time. So now if we click play, we're able to see that each time it starts at a random coordinate. So every time I click space, it starts at a random coordinate. However, it's still just going in a straight line. This is because we haven't given it any direction yet. So let's create a script called maze direction. CS underscore maze direction. This is going to hold an enumeration of all the possible directions. So let's delete that. I'll put public enum maze directions. I'll put inside it north, east, south, and west. So now we want to create another static class that's going to contain a function that returns a random direction. So I'll just put it underneath, public static class, and we'll just call this, change this to maze direction, and we'll just call this maze directions. So we'll create a constant called count, and this will simply hold the number of different directions possible. Now there are only 4 directions, as we're using a quad with only 4 sides. So the count here just allows us to have an official way of storing the number of directions possible, preventing the use of magic numbers. So now we want to create a function that returns a random direction. So we click public static. It's going to return a maze direction, and it's become called random value. So we'll get and return maze direction. So we're going to convert a random number between 0 and count, so a random number between 0 and 4, and it will convert it to a maze direction. So north is 0, east is 1, south is 2, and west is 3. So now that we've got a way to retrieve a random direction, we need to convert that direction into coordinates. So this can be done by creating a vector2 array. So inside of this class, we want to create a private static int vector2 called iVectors. So the vectors have to be in the same order as the maze directions. So north, new int vector2, would be 0 on the x-axis and 1 on the z. So we'll name this north. New int vector2 would be the other way around. So east is 1 on the x-axis and 0 on the z. So south is the opposite of 0. So it's 0 on the x-axis and -1 on the z. And lastly, west is -1 on the x and 0 on the z. Now we need to create a simple function to return the int vector when we're taking a direction. So we'll call it public static int vector2 to int vector2. So we'll want to put in a maze direction Now to make it easier, we can make an extension method of the maze direction simply by adding this. So what it's going to do, it's going to return a corresponding vector of the direction inputted. So here it's going to find the direction, convert it into an integer, and collect the vector of the according integer. So now in maze we can implement a getCell function. So if we go to maze, so this will return a cell at given coordinates. So if we put public this maze cell getCell vector 2, so we'll input coordinates and it will simply return the cell at the corresponding coordinates. This will be useful when we want to check if a cell has already been activated. So we'll also need to be able to change the generate function to only create a new cell if a cell hasn't been created in the new coordinates, and we need to add direction. So if we go to our generate function, so in the while loop, we want it to only proceed if also the cell at the I coordinates equals null. So it hasn't been assigned a cell. And the coordinates will now add maze direction random value to int vector 2. So this will add a random direction value to the coordinates each time. So we'll save this, and now when we click play, we'll be able to see that the maze generates a small random walk. However, as you can tell, this is nowhere near a complete maze. This is because when the maze chooses a cell it's already chosen, it immediately stops. Therefore, we need to implement backtracking and a way to store the cells. So for this to work, we need to make sure that maze contains the system collections generic function. Systems collection generic function, as we want to be able to create a list. Now we want to create two functions, so right at the bottom we'll create private void do first generation step. So we want two different steps, one for the original step and one for the others. So the first generation step will create a cell at random coordinates. So implement a list of maze cell, call it active cells. So it's taken a list and simply add a new cell to the active cells list. So create cell random coordinates. Here we're using create cell as a method to return a new cell instead of a void function. So we need to change that to here. So this will be maze cell and it will return a new cell. So now for the second one, we need to add a little bit more. So first, private void do next generation step. This will also take in a maze cell list. Now we want to create an integer to store what index we're at. So we're going to call it current index, and it's going to equal to the active cells count minus 1. So let's create a new cell called current cell, which is going to be stored in the list at the current index. We need to set the direction to be random, so we'll declare a new maze direction called direction, and it's going to be equal to maze directions.random value. So this will return a random value and store it within the direction itself. And it also needs some coordinates that will be equal to current cell coordinates plus the direction 2 in vector 2. So this will add the direction to the coordinates, given direction to the cell itself. We first want to check if the coordinates are within the grid. And we also want to get cell coordinates to be equal to null. So this is the same as we did in the generate function, because we'll be using this to replace it. So it's going to add a new cell to the active cells list at the current coordinates if no cell has been created there and it's within the grid itself. Otherwise we want to remove the current index from the active cells. So remove at current index. Now we need to implement these functions within the generate method. So first, let's scroll it. We're going to create a temporary list, so list of CS maze cells. We're going to call this active cells, and it'll be equal to a new list of maze cells. So then we want to call the do first generation step and input our active cells. So now this can be deleted as we're doing that within generation step itself. So this is also checked in the next generation step. So delete this, and we only want to do the next generation step if there are active cells left. So if the count of active cells is bigger than 0. Now we can delete all of this because this is also done in next generation step, and simply put do next generation step and input our active cells list. So now if we save that and click play, you can see that it will generate a much larger walk. So now we want to connect the cells. To do that we need to create the edges that will consist of passages and walls. So let's add a script for maze cell edge. This will keep track of the connections between the cells. We are going to give it a reference to the cell it belongs to and the neighbouring cell, the edge it also connects to. So we give it a public maze cell reference to current cell and its neighbouring cell. And it also needs a maze direction. We want to make the edges the child of their cells and place them in the same location. So let's create an initialize function. We can delete all that and create public void initialize, which is going to take in the current cell, the neighbouring cell, and the maze direction. So first we want to set all the input values to the variables we declared. So this cell, this current cell equals the current cell we inputted. This neighbouring cell equals the neighbouring cell we inputted, and this direction equals a__ direction. So now we want to make it a child of the cell itself. So to do that we do transform parent equals the current cell's transformation. So that will set the maze cell edge to be a child of the current cell. And we want it, the actual local transformation, to be at the centre of the current cell. So it'll be vector 3, 0. So in the maze cell script we need to create an array of all the edges. And this will be a size of 4, as there's only 4 edges to a square. delete all that. So I'll create private maze cell edge edges. And this will create new maze cell edge of maze directions dot count. So this will be a size of 4, as there's only 4 edges to a cell, although we put maze cell count just to make it look neater. So now I have a public maze cell edge that will call get edge. If you input a maze direction, it will simply return the edge at that direction. So what to do is return the edge array. We want to convert the direction to an integer. So if we go east, it will return the edge on the east side of the cell. We'll also create a set edge function, as it's bound to come in useful later. So this will take in the maze direction and the maze cell edge we want to set the edge to. So simply grab the edges array, convert the direction to an integer, and it will equal _ edge. So now if we go to the maze cell edge initialize function, we want to set the current cell, so set edge to direction and this. So this states that whatever type of cell edge, passage or wall would be inputted here. When we create a new edge, we need to declare it as either a passage or a wall. So we need to add passage and wall components of maze cell edge. To do this, maze cell edge needs to become an abstract class. So we don't need to create an instance of the generic maze cell edge, it's just its extended components. So now let's create 2 scripts. One for maze passage and one for maze wall. So now instead of mono behavior, in the maze wall and passage we want to put maze cell edge. And we do this for the passage as well. This will make an extension from maze cell edge. Now we need to create prefabs of both. So now we need to create prefabs for both the wall and the passageway. So we go to game object, create empty, and we'll call this maze passage. What we'll do, we'll drag the maze passage script onto the maze passage. And then we also need to do this for the wall. So let's create empty, maze wall, and drag the script to it. Now the wall is going to have some physical component to it. So we're going to create a game object, and this time it's going to be a cube. I'll call this wall. Now I'm just going to make sure this is centered. So if I put 0, 0, 0, 0, 0, 0, and I'm going to change the wall's transformation to 0.5 or 0.0 to 0.05, and the position to 0.5 and 0.475, as this allows it to align with the grid. So now we can drag the wall onto maze wall to make it child, and it will create those prefabs by dragging them down to the bottom. Also going to quickly add a material, and let's create material, let's call it red, and this will just be for the wall to make it seem stand out a little bit more. So let's drag that onto the wall So delete that prefab and then drag the new one down. So now with the prefabs, we can go into the maze script and simply add prefab to both. So maze cell passage, prefab, and maze cell wall. And we can add those prefabs into the maze. So maze passage, dragged up here, and maze wall there. So now we can create passages in the walls. So firstly, we want to add opposite direction to the maze, making sure that they're in the same order as the directions enum. Let's go to maze directions. Okay, private static maze direction opposites. So first was north, so here first has got to be south. Second was east, so next has got to be west. Then it was south, so we put north, and then lastly east. Then we need a simple retrieval function that will take in a direction and output the opposite. So we put public static maze direction. Simply call it get opposite. So again, it's this. I'll take in a direction, and it will simply return the same value in the opposite array. Now we want to create functions that create and initialize the walls and passages. So first we want to private void create passage, and this will take in maze cell and also the neighbouring cell, and it'll also take in direction. Will instantiate the maze wall prefab as maze wall, and we'll also initialize it with the current cell, the neighbouring cell, and the direction. So the wall is slightly different to the passage as it won't exist on the edge of the grid. So if the other cell, if the neighbouring cell does not equal null, so if it's not outside of the grid, then we can instantiate the opposite wall. So maze wall, and we want to initialize that as well. So now we can implement this new code into the generation step. So if we go to do next generation step, so now if it contains coordinates, we will take away this function. We'll create a new maze cell and call it the neighbour, which will equal get cell at the coordinates. Now if the neighbour is null, so if the cell adjacent to the current cell has not been activated yet, we want to create a cell at the coordinates. So initially we want to create a passage at every cell wall edge. So to current cell, neighbour, direction. And then the active cells goes within the neighbour null, and instead of adding a new cell, we simply add the neighbour. So if the neighbour does not equal null, so if the neighbour already exists, then we want to separate the neighbour and the current cell with a wall. So we do that with an else statement and create wall at the current cell, neighbour, and direction. We also want to remove the neighbour from the active cell's index. Remove at current index. So this is all the code for inside the grid. However, if the coordinates land outside the grid, then we want to create a wall, as this will create the walls on the outside of our maze. Now, as you can see, the neighbouring cell here is null because there is no neighbouring cell. And we also want to remove that the current indexed from our list again. One last thing to implement is the rotation, because right now all the walls are facing one way. We do this similarly to the opposites. So in maze direction, we want to create a private static quaternion array simply called rotations. Once again, this has to be in the same order as the maze directions. So north, originally all are rotated according to north. So the first one is simply the identity. So now we want to rotate it 90 degrees from north to go into the west direction. And this is rotated around the y-axis for it to remain in the xz plane. So next one will rotate 180 and it will each go up by 90 degrees each time. So now we're going to create a simple function to return the rotation if given a directional input. So this is similar to the getOpposite function, so I'll make it public static, but this time it will be a quaternion to rotate. So once again, taking this maze direction, and it will return the corresponding value in the quaternion array. So now we'll quickly go to the initialize function in the maze cell edge, and we'll add a transform local rotation to equal the direction to rotate. So now this is all good, but it still doesn't cover the entire grid. So now if we click play, we can see that it's creating walls when it goes back on each other, but it's still not covering the entire grid. So we need a better way of keeping track of the cell edges. So in maze cell, we want to be able to keep track on how often a cell has been set. So private int, and this would be initialized edge count. And we'll create a public boolean called is fully initialized. So this will return true if all the edges on a maze cell has been initialized. So we want it to get and return the initialized, so return true if the initialized edge count is equal to 4, which is the maze direction dot count. Now in the set edge function, every time we set an edge, we want to add 1 to the initialized edge count. So this will keep track of how many edges are created on a cell. Now the maze generator will need to choose a random uninitialized direction. So this will stop it from stopping after a few cells have been created. So in maze, we want to call a public maze direction random uninitialized direction. So here we'll choose a random uninitialized direction by creating a skip function. So in maze cell, now the maze generator will need to choose a random uninitialized direction. So we'll create public maze direction random uninitialized direction. Now we'll do a get function. So let's first input a skips integer, which will equal a random number between 0 and the available edges to initialize. So this will equal 4, which is the maze direction dot count minus the initialized edge count. So that'll be 4 minus how many edges have already been initialized. So now we're going to run through the edge array and see when there's a hole, so when the edge equals null, we'll check how many skips are left. So 4 int I equals 0, I is less than maze directions dot count and I++. So if edges at I equals null, so if there is a hole, then we want to see if we've got any skips left. So skips equals 0, then we want to return the maze direction. So if there are no skips left, that's the direction it chooses. So we'll return the maze direction at I. However, if the skips does not equal 0, then we want to minus 1 from the skips. So what this will do, this will check the edge array, check that if there's any skips left, it chooses the current direction. However, if there's no skips left, it decreases the number 1. So initially, the skips are a random number between 0 and the number of walls available. Then we need a for loop to loop through the array of edges on the cell. If the edge hasn't been initialized, and if we have no skips left, we return it. So currently this will return an error, as it doesn't always return a result. So if everything's right, it will never need to return maze direction at the end. But we still need a fallback. So after the for loop, we just want to throw new system invalid operation exception. So we'll pop a useful error message that will output the output log if ever caught. So I'll put it something along the lines of maze cell has no uninitialized directions left. Now all we need to do is implement these new functions into the generation step. So if we go to maze, I'll go to next generation step. Under current cell, we want to do if the current cell is fully initialized, then we want to remove it from the active cells list. At the current index and return. So it won't follow through with this. And now, because it removes the current cell only when it's been fully initialized, we can remove these functions here. So now when you click play, you can see it generates an entire perfect maze. This can be done with any size, so if I stop this and change the maze to a 4x4, it will randomly generate it each time. Thanks for listening.